A house appears on a lot. The neighbors assume it was built the usual way, board by board. But this house was not built on that lot. It was built inside a factory, 200 miles away. The hidden engineering inside modular home factories challenges almost everything construction takes for granted. Most people hear modular and think trailer park. That reaction is the first misunderstanding worth correcting. A modular home is not a mobile home. It is built to the same local building code as any site-built structure. The difference is where construction happens, inside a climate-controlled factory, not under open sky. That single change, moving the work indoors, creates a cascade of engineering consequences most buyers never see. To understand what those consequences look like, start on the factory floor. It looks nothing like a construction site. Workers move between fixed stations. Modules travel down a production line, like vehicles on an assembly track. But here is what makes it different from a car plant. Each module is a piece of someone's future home. The first station builds the subfloor and chassis on heavy-duty jigs, ensuring the frame is perfectly square and level. If the frame drifts even a few millimeters, the module will not join its neighbor at the building site. That tolerance is the quiet rule governing the entire operation. Every wall, every pipe, every wire must hit its mark. The next station frames the walls. Automated saws cut lumber or steel components to precise lengths for a consistent fit. Then licensed trades install wiring, plumbing, and HVAC ductwork directly into the framed walls while they remain open. On a traditional job site, those rough-ins happen after the walls go up. Here, the walls are still accessible. That access changes everything. Inspectors can see every connection before drywall hides it permanently. And this is where the quality argument becomes concrete. Factory inspection is continuous, not staged. A traditional build might see an inspector at 3 or 4 major milestones. A factory module is checked at every station. Insulation, vapor barriers, and exterior sheathing come next. Interior drywall is hung, taped, and finished. By the time a module leaves the factory, it is often 90% complete. Cabinets, flooring, fixtures, trim, and paint are done. That number sounds impressive, but the harder engineering is not finishing the module, it is moving the module. And the engineering required to survive that move is the part that separates modular from everything else. Because a modular home must do something no traditional house ever has to do. It must survive a highway trip. A module travels on a flatbed truck, sometimes for hundreds of miles, through wind, vibration, turns, and braking forces. The structure must resist lateral loads that a house sitting on a foundation would never experience. This is why modular homes are often engineered to be 20 to 30% stronger than equivalent site-built structures. That extra strength is not a selling point. It is a survival requirement. Without it, the module arrives damaged. Besides, if you thought the factory was the hard part, the road changes the equation entirely. Transportation constraints dictate design before a single wall is framed. Module width cannot exceed highway limits. That means roughly 14 to 16 feet wide, depending on the state. Height and length face similar restrictions. Oversized loads require special permits, pilot escort cars, and restricted travel routes that avoid low bridges and narrow roads. The route survey happens early. A bridge too low or a turn too tight can force a complete redesign of the module, and the modules must arrive in the right order. Early delivery creates storage problems. Late delivery idles the crane. That just-in-time coordination makes the supply chain feel more like aerospace logistics than residential construction. Once the truck reaches the site, a crane lifts the module onto the prepared foundation. This operation is measured in hours. A traditional framing crew might need weeks. A crane can set an entire house in a single day, but crane time is expensive. Inefficient sequencing or misaligned foundations waste money at a rate construction rarely encounters. The foundation must match factory specifications exactly. If it does not, the modules cannot connect properly. Bolted or welded connections at module joints must meet structural standards for seismic and wind loads. Then specialized crews finalize the mechanical, electrical, and plumbing connections between modules. Those hookup tasks require skills that most general contractors do not carry. It is a niche within a niche. The result, when it works, is a completed home in a fraction of the time, 30 to 50% faster than traditional construction. And site preparation runs in parallel with factory fabrication. The foundation is poured while the modules are being built. That parallel processing is the biggest time advantage. Two work streams that never wait for each other. Now the question becomes obvious. If modular is faster, stronger, and more inspected, why is it still rare? In the United States, only about 3% of single-family homes completed in 2024 used modular or panelized methods. The market for permanent modular construction reached roughly $20 billion. That sounds large until you measure it. Against total U.S. construction spending, modular accounts for about 5% of activity. A sliver, not a movement. Meanwhile, in Sweden, approximately 84% of detached homes are built using factory-based methods. In Japan, firms like Daiwa House have been manufacturing homes on assembly lines since the late 1950s. Japan's share of factory-built housing sits between 15 and 28% of new homes, depending on the measure used. So the technology works. Other countries proved it decades ago. Why has the U.S. market stayed so small? The first barrier is regulation. Building codes vary by jurisdiction, sometimes city by city, county by county. A home manufactured in one state may face a different code when shipped to another. Compliance is not portable. That patchwork creates friction that mass production cannot tolerate. Factories need volume and consistency. The second barrier is financing. Traditional construction loans pay out in stages based on visible on-site progress. Modular construction loads costs at the front. The factory needs payment before the module reaches the site. Lenders built their systems around dirt and concrete, not factory invoices. The mismatch slows adoption. The third barrier is stigma. Many buyers, and even some lenders, still confuse modular homes with trailer homes. That confusion is not rational. Modern modular homes meet the same codes and often exceed the durability of site-built homes. But perception shapes markets, and the word prefab still carries decades of old associations. This is the contradiction at the center of the industry. The engineering is ahead. The market is behind. Some companies tried to force the gap closed. The results were instructive and sometimes painful. Katerra, once valued at $4 billion, collapsed in 2021. It tried to vertically integrate modular construction at speed. The overhead of running factories, managing supply chains, and navigating fragmented construction markets overwhelmed the model. Other startups followed a similar pattern. Vive, Ilcombs, and Modulus all faced insolvency or operational shutdowns. The lesson was not that factories cannot build houses. It was that factories cannot ignore the system around them. Codes, permits, transport rules, local labor, lending practices, and buyer expectations are all part of the equation. The companies that survive tend to focus on niches where reproducibility is high and regulatory complexity is manageable. Multifamily affordable housing is the largest segment. Rapid deployment projects prove the speed argument most clearly. Canada's Rapid Housing Initiative used modular construction to deliver 10,000 homes in 24 months. That project showed what modular can do when policy, funding, and demand align behind a single objective. But alignment is the rare ingredient. Most of the time, the system resists the very efficiency it claims to want. If the promise is real, the next question is mechanical. What happens inside the factory that makes the math work? Before a single board is cut, the design goes through building information modeling software. A 3D digital twin. BIM allows engineers to detect clashes between structural, electrical, and plumbing systems before production begins. A pipe that conflicts with a beam is caught on screen, not on the floor. That saves days and materials. Material optimization follows. Every cut is planned. Waste drops to a fraction of what a job site generates. Industry estimates suggest factory construction reduces waste by up to 90% compared to traditional building. That reduction is not just environmental, it is financial. Less waste means less purchased material sitting in a dumpster. The controlled environment adds another layer. Rain, snow, and humidity cannot reach the structure during assembly. Moisture damage is one of the most common quality problems in traditional construction. The factory eliminates it. Workers benefit too. Fixed stations with proper lighting, tools, and ergonomic setups reduce injury rates. The labor argument matters because construction faces a severe shortage of skilled workers in the United States. Factories can train workers in specific station tasks. A framing specialist does not need to know plumbing. That specialization mirrors manufacturing, not construction. And it is one reason the industry struggles with its own identity. Is modular construction a construction method, or is it manufacturing? The answer determines how the market treats it. If it is construction, codes and unions apply in familiar ways. If it is manufacturing, different rules and expectations follow. That identity question has not been settled. And until it is, modular exists in a regulatory gap that creates both freedom and friction. Now the financial picture becomes clearer. The market is growing, but slowly. Roughly 5% annual growth is projected through 2030. The growth is driven by housing shortages, labor gaps, and the demand for faster, more predictable project delivery. But the ceiling is set by the same forces that have always limited modular: codes, capital, perception, and fragmentation. Why matapanained? There is one more hidden layer. The engineering inside the module must also solve for sound, fire, and energy. Sound transmission between modules requires specialized gaskets and decoupled wall assemblies at every joint. Fire rating demands continuous barriers that cannot be broken by the gap between two factory-built boxes. Energy performance depends on airtight seals that must hold despite the module having traveled hundreds of miles on a truck. Each of those requirements adds engineering cost, but each also raises the quality floor above what most site builds achieve. The paradox is that modular homes are often better built, yet harder to sell, than their site-built equivalents. Sweden solved this by making factory construction the default. The stigma never took hold because the quality was always visible. Japan solved it differently. Massive firms like Sekisui House integrated design, manufacturing, and after-sales service into one brand. Those brands earned trust through decades of reliable delivery, earthquake resistance, and customer service, not marketing slogans. The US has neither default nor dominant brand. It has a fragmented landscape of small factories and skeptical buyers. That fragmentation is the real barrier, not the engineering, not the math. The system around the product. A factory can build a better home, but a factory cannot build the financing, the code uniformity, or the public trust. Those require a different kind of engineering, the kind that redesigns markets, not just structures. The housing shortage in the United States continues to deepen. Estimates vary, but the gap is measured in millions of units. Modular construction offers one path to close that gap faster, but the path runs through problems that no factory can solve alone. The economic lesson is the same one hidden inside every machines and margins story. Technical capability is necessary, but it is never sufficient. The system around the product determines whether the product reaches the market. Modular home factories have solved the engineering. They have not yet solved the market. And solving the market may require changes that look nothing like construction or manufacturing. Policy, lending reform, code harmonization, and a slow, patient shift in how buyers think about where a home is made. The next Machines and Margins documentary follows another system where the hidden constraint is not technology, but the rules around it. Because sometimes the most advanced factory in the world still waits for the market to catch up.